We know for sure that the universe will have a more time in the future than we have had in the past. But I should also say, this idea of a universe as being the be-all and the end-all might be kind of naive. And we now take seriously the possibility that our Big Bang wasn't the first or the last. That what we call the beginning of our universe, which is this incredibly high energy event where the universe comes out, incredibly rapid growth, full of hot, high energy stuff, that event, the Big Bang, was not actually the beginning of the cosmos. It was the beginning of our little observable patch, and it's as far back as we'll ever be able to see. But maybe we are just sort of one plume off of kind of an infinite and permanent and infinitely old sort of space-time. Used to be called a megaverse, but now people call it the multiverse. And there are an infinite number of other bubbles with their own Big Bangs. And some of those universes never got this far. Some of those universes expanded just for an instant and then recollapsed and were gone. There were no galaxies, no stars, no carbon, no oxygen, no life forms, and their futures were very short. And we happen to live in this multiverse picture in a universe that survives for a long time, which is kind of crucial if you're going to have life forms. So we know we're not a first generation of stars. We know right after the Big Bang, there's like nothing but hydrogen and helium. I mean, the universe is really simple, and you can't make a rocky planet, let alone a human being. And you need stars to perform thermonuclear fusion to turn that stuff into complex elements. And then those stars have to blow up because they have to give those elements back to the universe if they're going to be used for something good. And so we're second generation material of stuff that was once internal to other stars. And so we're absolutely in a very complex kind of ecosystem that requires time for it to all play out. And not all these other universes have a lot of time. Some of them maybe live forever, but they expand so quickly, they cool so quickly that they never make stars. They have incredibly long, empty futures where they reach that kind of metabolic death state right away. And so they also don't have life forms. I don't really like these suggestions, but some people say, well, maybe the reason our universe is the way it is not so much to be tuned for life in some kind of meaningful way, but just, we're here, so we must live in a universe that allows for life, and so maybe this is rare. Maybe this is just rare. So ever since we realized that the universe had a beginning, it sort of changes the way we think about our time here. I mean, before we understood that there was a Big Bang and that it happened 14 billion years ago, people thought the universe was permanent, that it always existed and that it always would exist. And even Einstein didn't want to believe this nonsense about a Big Bang. He really tried hard to alter his theory so that wouldn't happen, so the universe would be permanent. And he did capitulate. He realized that it was a big mistake, that in fact the universe had a beginning. And so once you realize that, 14 billion years ago sounds like a long time, but we're actually just in the beginning of the whole thing. Once you realize that the universe had a beginning, you're able to start to ask, well, will it last forever? Will it go on infinitely in the future? And there's some sense in which the universe will have a metabolic end, one way or another. We don't know which specific end we're heading towards, but we know that one way or another the universe will have some kind of metabolic end. We look out in the sky and we do all this astronomy because we see stuff that's really far away and the light travels billions of years to get to us, and we see really deep into the cosmos, but eventually that won't be possible. Eventually everything will be so far away that they will effectively go dim for us, and then the sky will go dark. And And even if we hadn't yet fallen into a black hole, there's really nothing left to see. So in the very far future, there's this sort of metabolic death of the universe where it's just kind of doesn't change anymore. It's just a couple of bits of things in the entire observable universe, and they just don't change much. And without that change, there's sort of no clocks anymore. There's nothing to measure entropy increase or passage of time. And that will be kind of a conceivable end fate for our universe. Yeah, I mean, I think one of the interesting things about mathematics is that it finds lots of different applications. So when I talked about how the universe got its spots, the reference was because it's the same mathematics juiced up a little bit to do curved space-time and relativity, but essentially a very similar mathematics to that's required for the problem of how the leopard gets its spots. And it has to do with fluctuations and hot and cold spots, or in the case of the leopard, low and high concentrations of enzymes in the developing fetal environment. And so it's just kind of amusing that mathematics maps itself to lots of different problems. And the universe might get its spots. In this case, the spots are hot and cold patches in the light left over from the Big Bang, as a result of very similar mathematics as to, the leopard. Well, some people will say, look, a numerical experiment is an experiment. So Kip Thorne, who's a famous black hole theorist, was recently talking about simulations that they did for Interstellar. And they used his math, so they're accurate. And he says a simulation produces data, right? And that's true. It's numerical data, but it's a kind of data. So in some sense, you could say any experiment I perform in the lab is like building an electromechanical computer of sorts. It's just a bespoke one that only does that one operation. And the data that I get having to do with the responses of things in the room, why is that more real than this other electromechanical machine, which is doing things and creating data? I think there's an interesting philosophical argument there. Nobody anymore really says, oh, that's just a simulation, it's not real.